Assalamu alaikum. Welcome to my statistics class. Beloved students, English version day shift, especially the students of class 12, those who have the subject statistics. Today, I, Muhammad Ashraful Azim, shortly aged, is going to deliver the third lecture on the chapter 5 of statistics second paper, namely Poisson distribution. Dear all, in my previous class I have discussed the basic of the chapter. Side by side I have solved the problems. Today we are going to solve a word problem, that is the application of the chapter. The problem is 0.1% of the products of a factory are defective. 100 items are taken from a day's production. Find the probability that of them, number 1, none is defective, number 2, at best one is defective, and number 3, at least one is defective. So firstly, to solve the problem, we have to know which distribution follows the problem is. Here 0.1% be the probability and number of items is 100. We know when number of trial is very large, here large means greater than 30, and probability of success is very small, that is tends to 0. In that moment, binomial distribution tends to Poisson distribution. Since these two items, that is P and N, that is probability of success is very small and number of trials is very large, that is it's clear to us that the distribution have to solve by Poisson distribution. So what is the probability function of Poisson distribution? Firstly you have to know, and we know the probability function of Poisson distribution is P of x equal to e to the power minus m to the power x divided by x factorial. Now let's see the solution of the problem. I mentioned a few seconds ago that firstly you have to know, is the problem follows Poisson distribution? Now we'll check. Here probability of success is given that 0.1%, and probability of success means our query we want to determine the probability of defective items. So to find the defective items is the success. Here we consider the probability of defective items by P. So let P be the probability of defective items. Later on, probability of success is denoted by P, which is given that 0.1%, that is 0.1 by 100, which is equal to 0.001. Now number of defective items is denoted by X. We consider X be the variable which indicates the number of defective items. Number of trial is given 100. There are 100 items in the question, it is mentioned. So let us consider number of trials n equal to 100. Now m is a constant which be the product of n and p, that is number of trials and probability of success. As a result, replacing the values of n and p, we get 100 into 0.001, which is equal to 0.1. So m equal to 0.1. Now the decision, since the value of n is very large and p is very small, that is why the distribution follows the Poisson distribution. That means we have to solve the problem by using Poisson distribution. We know in Poisson distribution there is only one parameter, and which is denoted by m, and we obtain the value of m, and that is m equal to 0.1. Now the probability function of Poisson distribution, which is p of x equal to e to the power minus m to the power x divided by x factorial, where x equal to 0, 1 to up to infinity. Since the value of m is 0.1, that is why replacing the value of m, we get this is e to the power minus 0.1 into 0.1 whole to the power x divided by x factorial. So to solve the problem, we obtain p of x equal to e to the power minus 0.1 into 0.1 to the power x divided by x factorial. Now the first problem is find the probability that none is defective. So none is defective, that is there is no defective item. So x equal to 0, that is we have to determine probability of x equal to 0. On the above, we have probability of x equal to e to the power minus 0.1, 0.1 to the power x divided by x factorial. Here just to replace the value of x is 0, as a result we get p of x equal to 0, which is equal to e to the power minus 0.1 into 0.1 whole to the power 0 divided by 0 factorial. We know 0 factorial equal to 1 and 0.1 whole to the power 0, that means something to the power 0 equal to 1. So e to the power minus 0.1 into 1 divided by 1 equal to nothing but e to the power minus 0.1. Now using the scientific calculator, we get the value of e to the power minus 0.1 is 0.9048, which is the required probability of no defective items. That is, number 1 is solved. My dear students, the second problem is that what is the probability of that at best 1 is defective. So at best 1 is defective, maximum 1 is defective. So either no defective or at best 1 is defective. That is why it is denoted by probability of x less or equal to 1. So probability of x less or equal to 1, x be the Poisson variate and the least value of x is 0. So it is started from 0. It must not be negative. So probability of x less or equal to 1, it means probability of x equal to 0 and probability of x equal to 1. So probability of x less or equal to 1 equal to probability of x equal to 0 plus probability of x equal to 1. Similarly, we just replace the value of x equal to 0 and x equal to 1 of the probability function. Just replace the value of x. So we get e to the power minus 0.1 into 0.1 whole to the power 0 divided by 0 factorial plus e to the power minus 0.1 into 0.1 whole to the power 1 divided by 1 factorial. Again, using the scientific calculator, we get this is 0.9048 plus 0.9048 into 0.1, and finally the sum is 0.9953, which is the required probability of the defective items at best 1. So the probability of at best 1 defective item is 0.9953. Later on, there is another problem, which is we have to determine the probability of at least 1 is defective item. So at least 1 is defective. There is lot of defective items, maybe at least 1, maybe 2, maybe 3, maybe 4, maybe up to 100. Here maximum value 100. So probability of x greater or equal 1, it means at least 1 is defective items or more than 1. So if we expand probability of x greater or equal 1, then we can write it such a way that probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 and so on. And here we know that total probability is 1, so this is can be expressed in such way that 1 minus probability of x equal to 0. So total probability, if we subtract probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 up to infinity from total probability, that is 1, then we get it is 1 minus probability of x equal to 0. Now 1 minus probability of x equal to 0 means 1 minus e to the power minus 0.1 into 0.1 whole to the power 0 divided by 0 factorial, that is 1 minus 0.9048, and the difference is 0.0952, which is the required probability of at least one item is defective. This is the complete solution of the given problem, that is find the probability that of them none is defective, at best one is defective, and at least one is defective. And such way you have to solve the problem. The chapter is very easy and short, so if you learn the chapter very clearly, in that moment you will get a creative question and a system like this. That is, if you able to solve the problems, word problems, and the basic of the chapter is clear to you, in that moment you will be able to solve the creative questions. 1 or 2 class later I will provide the creative questions. Now I expect that you are understood how can you solve the problem, and related to the problem there is another problem which is provide you as homework, which is 2% of the manufactured products of a factory are defective. Out of 100 products, find the probability that of them none is defective, at best 2 are defective, at least 1 is defective, and 2 are defective. After solving the problem, you will get the answer of 1 is 0.1353, answer 2 is 0.6767, number 3 is 0.8647, and number 4 is 0.2706. And you I expect that you'll be able to solve the problem, and in the next class we'll solve different types of word problems. And no more today. Dear all, stay well. Thank you very much. Allah Hafiz.